Welcome again to Astronomy Daily. I'm your host, Steve Dunkley. It's the 3rd of February, 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Yes, welcome back one and all. Today, Hallie will present February's Planet Parade for you. It's a bumper story, so stay around for that one. Also, she's talking briefly about something very interesting from the Russian Institute of Biomedical Problems. Hallie, what's going on there?
Hi, favorite human.
G'day.
In true Russian pragmatic style, they've completed a fascinating mission to the moon without leaving Earth.
Okay, that's a neat trick.
They are clever.
And I hope you're going to tell us all about it.
So more on that soon.
Very good.
And there's more from the Astronomy Daily newsletter in today's episode, of course.
And we'll let you all know how you can receive that newsletter in your email every day so that you can be across all the news, events and research happening in orbit and beyond. Right, Hallie?
That's right, human. There's something different every day.
Okay, so why don't we just launch right into the stories we've collected from the newsletter for today. I'm looking forward to your Planet Parade today, Hallie.
That's always a great revelation to what's happening.
Yes, the February sky.
There are some nice highlights to look forward to.
Okay, so let's get to it, stargazers.
Let's go. On November 14, 2024, the Institute of Biomedical Problems, IBMP, of the Russian Academy of Sciences marked the successful completion of Sirius 23, a year-long biomedical isolation experiment simulating the conditions of deep space travel and lunar surface operations. For 366 days, a crew of 6 analog astronauts lived and worked in a sealed environment, a meticulously controlled Earth-based stand-in for interplanetary missions of the future. The Sirius Scientific International Research in Unique Terrestrial Station project, launched in collaboration with NASA's Human Research Program and the IBMP in 2017, had previously conducted shorter experiments lasting 17, 120 and 240 days. These missions, featuring international crews from Russia, the United States and the United Arab Emirates, aimed to replicate the isolation and psychological strain of long-term spaceflight. However, after 2022, IBMP decided to proceed with the ambitious Sirius 23 experiment independently. The latest crew hailed from Russia and Belarus: Commander Yuri Chebotarev, Flight Engineer Angelika Parfanova, Medical Officer Ksenia Orlova, and researchers Olga Mastakaya, Ksenia Shishinina, and Rustam Zaripov, a mixed-gender team of 2 men and 4 women.
Astronomy Daily, the podcast.
As someone who is no stranger to dropouts on a planetary scale, Apollo 11 moonwalker Buzz Aldrin has teamed up with Verizon to help promote the company's satellite-based solution to cell-service dead zones of all things. Now the 95-year-old astronaut, who in 1979 became one of the first humans, the second in fact, to step foot on the lunar surface, appears in a new Verizon advert alongside Paul Marichelli, the original "Can You Hear Me Now" test man, to ask, "Can you text me now?" 56 years ago, he says, "I was one of the select few that made it into space and the first team to help America conquer the moon," Aldrin said in a statement released by Verizon. Back then, he says, space was the great unknown, and now we've never been closer to it. I can't look up into the sky without seeing a satellite fly by. It's remarkable to see how far the human race and technology has come. In the commercial, Aldrin is seen wearing a silver jacket adorned with the Apollo 11 mission patch while planting a Verizon satellite-powered red and yellow flag at remote areas around the Earth. At each stop, whether it be on the desert floor of a canyon, at the base of a snow-covered mountain, or in an area of wilderness already marked as a dead zone, the retired US Air Force General and Doctor of Astronautics uses his Verizon-issued Android smartphone to show that he can still send texts. Aldrin's last test is shown as looping out around the moon past an American flag planted on its surface to a satellite in Earth orbit. There, a space-suited Marichelli, without a helmet, receives Aldrin's message and reacts, "That's my line. It's been 10 years since I asked America, can you hear me now? Back then, dead zones were everywhere, and it's safe to say today that they are only in the most remote places, like the dark side of the moon," he said in Verizon's release, making the common mistake of describing the far side of the moon as the non-existent dark side. "Satellite is for sure the next frontier," he says. Verizon's customers with select new model phones and updated software can send texts such as emergency SOS messages, including their location when they are in areas inside the United States without cellular coverage. According to the company, its US network provides coverage to more than 99% of the places where people live, work and play, but its satellite service now covers the very few places throughout the country where customers cannot connect. For the service to work, the phones, which include Google's Pixel 9 series and Samsung's Galaxy S25, must be outdoors with a line of sight to the Viasat EchoStar or other satellites that are part of the Skylo satellite connectivity service. The service may not work in parts of Alaska. In addition, AST Space Mobile, a satellite designer and manufacturer based in Midland, Texas, has a $100 million commitment from Verizon to provide direct-to-cellular satellite service when needed for Verizon's customers. This week, the Federal Communications Commission authorized AST to begin testing its service in the United States. This approval enables the first 5 of AST's commercial Bluebird satellites already operating in low Earth orbit to test connections with Verizon smartphones supporting voice, full data and video applications, as well as other native cellular capabilities without the need of any specialized software or device support or update. That's one giant leap for connectivity, says Aldrin in the commercial. AST Space Mobile also has an agreement to provide space-based network services to AT&T and its customers. Similarly, T-Mobile partnered with SpaceX to use the Starlink broadband internet constellation and its direct-to-cell capabilities. This is not Aldrin's first appearance in a commercial. In the past, he has filmed ads for IBM and YouTube TV in 2019, a commercial for Quaker Oats in 2016, and in 2015 a promotion to visit Switzerland. In 1987, Aldrin joined Mercury astronauts Scott Carpenter and Gordo Cooper to advertise the Commodore Amiga 500 home computer. Oh, you remember that one? And in 1972, a year after he left NASA, Aldrin helped sell the Volkswagen VW Beetle, comparing its computer diagnostic system to the computer he used to fly to the moon. Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
A safety panel is calling on NASA to reassess plans for upcoming Artemis missions, arguing that the agency is packing too many objectives into each mission. At a January 30th public meeting of ASAP, the Aerospace Safety Advisory Panel members reiterated past concerns about the number of first-time objectives planned for Artemis 3, the first crewed lunar landing of the overall campaign, and later missions. Each first milestone carries its own individual risk and, as these risks are compounded and aggregated, it only increases the overall risk posture for any individual flight mission, said panel member Bill Bray. It begs the question, is it time for the agency to reassess the current mission objectives and its approach for Artemis 3 and beyond, with the goal to better balance the risks across all those flight tests? ASAP has previously expressed its concerns about the number of firsts on Artemis 3, such as in its most recent annual report released in early 2024. That report listed 13 separate firsts for the mission, mostly tied to the Starship lunar lander and new spacesuits being developed by Axiom Space. That list has only grown since then, he noted, with changes to the heat shield for Orion. NASA announced in December that it would reformulate the AVCOAT material used in the heat shield for Artemis 3 and later missions to prevent the heat shield erosion seen on the Artemis 1 re-entry. Those concerns extend beyond Artemis 3, Bray said, with later missions incorporating the Lunar Gateway, the Blue Moon crewed lunar lander and a lunar rover. Each of these elements under development and delivery requires a near-perfect program execution across a complex set of tests and milestones and, frankly, there's very little room for failure. Problems with a single key element, he concluded, will result in continued launch delays and an irregular and erratic cadence of mission flights, an issue ASAP has also previously raised. It also creates an increased risk posture for Artemis missions. Bray said that ASAP discussed the issue with Amit Kshatriya, Deputy Associate Administrator of NASA's Moon to Mars Program Office, at recent meetings. The panel urged NASA to treat each launch as a test objective, like the Apollo program, with clear test objectives that could be balanced across all launch events and ensure a more regular cadence of missions. He didn't disclose NASA's response to those concerns but said that ASAP will continue to press NASA to re-examine its Artemis mission plans and consider reallocation of test objectives to achieve a more regular launch cadence with a more balanced risk exposure.
Roger that, Control. We're listening to Astronomy Daily, the podcast.
The Gaia mission launched by the European Space Agency has completed a decade of groundbreaking astronomical observations, collecting over 3 trillion data points on 2 billion stars and celestial objects. The European Space Agency's Gaia spacecraft, which has been mapping the Milky Way, has completed its sky scanning phase. Over the past decade, it has made more than 3 trillion observations of around 2 billion stars and other celestial objects, transforming our understanding of our galaxy and surrounding universe. Gaia was launched on December 19, 2013, and after years of precise observations, its fuel supply is now running low. The spacecraft consumes about a dozen grams of cold gas per day to maintain stability and accuracy. However, the mission is not over yet. In coming weeks, Gaia will undergo a series of technology tests before being placed into its final retirement orbit. Additionally, 2 major data releases are planned, one in 2026 and another by the end of the decade, offering even more insights into our cosmic neighbourhood. Today marks the end of science observations, and we are celebrating this incredible mission that has exceeded all of our expectations, lasting for almost twice its original foreseen lifetime, says ESA Director of Science Carol Mundell. The treasure trove of data collected by Gaia has given us unique insights into the origin and evolution of our Milky Way galaxy, and has also transformed astrophysics and solar system science in ways that we're not yet to fully appreciate. Gaia built on unique European excellence with astrometry and will leave a long-lasting legacy for future generations. After 11 years in space and surviving micrometeorite impacts and solar storms along the way, Gaia has finished collecting science data. Now all eyes turn towards the preparation of the next data releases, says Gaia project scientist Johan Salman. I'm thrilled with the performance of this incredible mission and excited about the discoveries that await us. Gaia has been charting the positions, distances, movements, brightness, changes, composition and numerous other characteristics of stars by monitoring with its 3 instruments many times over the course of its mission. This has enabled Gaia to deliver on its primary goal of building the largest, most precise map of the Milky Way, showing us our home galaxy like no other mission has ever done. As such, we're now able to have the best reconstructed view of how the galaxy might look to an outside observer. This new artist's impression of the Milky Way incorporates Gaia data from a multitude of papers over the past decade. It contains major changes from previous models because Gaia has changed our impression of the Milky Way. Even basic ideas have been revised, such as the rotation of our galaxy's central bar, the warp of the disks, the detailed structure of spiral arms, and the interstellar dust near the Sun, says Stefan Payne-Wadner, the scientific visualizer for the Haus der Astronomie at Germany and the IAU Office of Astronomy for Education. Still, the distant parts of the Milky Way remain educated guesses based on incomplete data. With further Gaia data releases, our view of the Milky Way will become even more accurate. Gaia's repeated measurements of stellar distances, motions and characteristics are key to performing galactic archaeology on our Milky Way, revealing missing links in our galaxy's complex history, and that'll help us learn more about our origins. From detecting ghosts of other galaxies and multiple streams of ancient stars that merged with the Milky Way in its early history to finding evidence for an ongoing collision with Sagittarius dwarf galaxy today, Gaia is rewriting the Milky Way's history and making predictions about its future. In the process of scanning stars in our own galaxy, Gaia has also spotted other objects, from asteroids in our solar system backyard to galaxies and quasars, the bright and active centres of galaxies powered by supermassive black holes outside our Milky Way. For example, Gaia has provided pinpoint precision orbits of more than 150,000 asteroids and has such high-quality measurements as to uncover possible moons around hundreds of them. It's also created the largest three-dimensional map of about 1.3 million quasars, with the furthest shining bright when the universe was only 1.5 billion years old. Gaia has also discovered a new breed of black hole, including one with a mass of nearly 33 times the mass of our Sun. That one hiding in the constellation Aquila, less than 2,000 light years from Earth. The first time a black hole of stellar origin this big has been spotted within the Milky Way. It's impressive that these discoveries are based only on the first few years of Gaia data, and many were made in the last year alone. Gaia has been the discovery machine of the decade, a trend that is set to continue, says Anthony Brown, chair of the Gaia Data Processing and Analysis Consortium, and based at Leiden University in the Netherlands. The Gaia scientific and engineering teams are already working full steam on the preparations for Gaia Data Release 4, expected in 2026. The data volume and quality improves with every release, and Gaia Data 4, with an expected 500 terabytes of data products, is no exception. Furthermore, it will cover the mission's first 5.5 years, corresponding to the length of the originally foreseen duration of the mission. This is the Gaia release the community has been waiting for, and it's exciting to think that this only covers half of the collected data, says Antonella Valenari, Deputy Chair of DPAC, Instituto Nacional di Astrofísica Astronomica Observatory in Padua, Italy. Sorry about my pronunciation, folks. I'm Australian. Even though the mission has now stopped collecting data, it will be business as usual for us for many years to come as we make these incredible data sets ready to use, she says. Gaia Data Release Set 4 is set to expand its binary star catalogue, the largest such catalogue to date. Gaia has a unique ability to tease out the tiny motions of pairs of celestial objects orbiting close to each other, and has already spotted previously hidden companions around bright stars. Incidentally, Gaia's largest targeted observation on January 10 was a binary pair 61 Cygni. This iconic star attracted the attention of 19th century astronomers to yield some of the first proper motion and parallax measurements techniques used by Gaia on some billion stars. And astute science fiction readers will remember 61 Cygni from Clifford Seamack's wonderful story, Time and Again, starring the ineffable Asher Sutton. Gaia's exoplanet discoveries are also set to increase with the forthcoming data sets, thanks to the longer time frame of observations, making it easier to spot wobbling stars. Over the next few months, we'll continue to downlink every last drop of data from Gaia, and at the same time, the processing teams will ramp up their preparations for the fifth and final major data release at the end of the decade. This will conclude with an incredible coordinated effort between hundreds of experts across the Science Operations Centres here at ESAC, the Mission Operations Team flying Gaia from ESA's European Space Operations Centre in Germany, and a huge consortium of data processing specialists who have together ensured the smooth running of this beautiful mission for so long. While today marks the end of science observations, a short period of technology testing now begins. The tests have the potential to further improve Gaia calibrations, learn more about the behaviour of certain technology after 10 years in space, and even aid the design of future space missions. After several weeks of testing, Gaia will leave its current orbit around Lagrange Point 2, 1.5 million kilometres from the Earth, in a direction away from the Sun, to be put into its final heliocentric orbit, far away from Earth's sphere of influence. This spacecraft will be passivated on 27 March 2025 to avoid harm or interference with other spacecraft. During the technology tests, Gaia's orientation will be changed, meaning it will be temporarily become several magnitudes brighter, making observations through small telescopes a lot easier. It won't be visible to the naked eye, though. A guide to locating Gaia has been set up, so amateur astronomers are invited to share their observations. Gaia will treat us with this final gift as we bid farewell, shining amongst the stars ahead of its well-earned retirement. It's a moment to celebrate this as this transformative mission and thank all the teams for more than a decade of hard work operating Gaia, planning its observations and ensuring its precious data are returned smoothly to Earth.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
February brings a rare planetary parade, with 5 bright planets in clear view and a special alignment of Mercury and Saturn on February 24th. Throughout February, a striking gathering of the 5 brightest planets, Venus, Jupiter, Mars, Mercury, and Saturn, along with the more elusive Uranus and Neptune, will be the main celestial attraction in the evening sky. Later in the month, anyone with a clear, unobstructed view of the horizon may be able to see all 5 bright planets stretching across the sky. 2 of these planets, Mercury and Saturn, will appear especially close together on Monday, February 24th, the highlight of this month-long planetary display. While this planetary alignment isn't particularly rare, it is relatively uncommon. Spotting 2, 3, or even 4 bright planets at once is not unusual, but the chance to see all 5 together doesn't come around often. Looking ahead, a similar alignment will occur in late October 2028, though that event will take place before sunrise, requiring early risers to catch the view. By far, the most prominent of the 5 planets is Venus. Although it reached its greatest angular distance east of the Sun on January 10th, it continues to shine brilliantly in the west-southwest sky at dusk throughout February, a breathtaking evening lantern. Venus will remain at peak brightness for much of the month, and if you observe it through steadily held binoculars or a small telescope, you'll see it as a crescent. As February progresses, Venus's disk will appear larger as it moves closer to Earth, while its crescent thins as the planet aligns more closely with the Earth-Sun line of sight. The next planet to spot is Saturn, the famed Lord of the Rings. To find it, simply look toward Venus and extend an imaginary line straight downward. The first bright star-like object you come across will be Saturn. Your first impression might be, wow, it's so dim. But in reality, Saturn shines as brightly as a first-magnitude star. However, when compared to Venus, which is a full 6 magnitudes brighter, Saturn appears significantly fainter, only about 1/250 as bright. Saturn is typically more radiant, but right now, its ring system is nearly edge-on from Earth's perspective, contributing little reflected light. To catch a glimpse of the rings, now appearing as a thin, bright line bisecting the planet's disk, you'll need a small telescope with at least 30x magnification. During the first 2 weeks of February, watch as the gap between Venus and Saturn gradually widens. In the second half of the month, Saturn will become increasingly difficult to spot against the brightening evening twilight, eventually fading into the sun's glare by month's end. Then there's Jupiter, unmistakable with its silvery white brilliance, though only 1/10 as bright as Venus. The largest planet in our solar system appears high in the south at dusk, accompanied by 2 famous naked-eye star clusters, the Pleiades and Hyades, as well as several bright winter stars. The most notable is the orange-hued Aldebaran, positioned just below Jupiter. With binoculars or a small telescope, you can also spot Jupiter's 4 largest moons, first observed by Galileo in 1610 with his crude telescope. Make a special effort to view them on the night of February 25th to 26th, when 3 of them, Europa, Ganymede, and Callisto, form a strikingly tight triangle on one side of the planet, while Io sits alone on the other. The triangle will appear tightest at 12:39 a.m. Eastern Time on February 26, 5:39 GMT, or 9:39 p.m. Pacific Time on February 25th. Now, look halfway up in the eastern sky for orange-yellow Mars, which blazes into view as night falls. During February, it is accompanied by the twin stars of Gemini, Pollux and Castor. This striking trio spends nearly the entire night crossing the sky, forming a distinctive triangle that gradually shifts in size and shape as the month progresses. Mars was at opposition and closest to Earth in January. During February, as Earth moves ahead in its orbit, Mars lags behind, causing it to fade by about 3/4 of a magnitude over the course of the month. The fifth and final planet is the smallest in our solar system, Mercury. This rocky little world becomes visible during the final week of February, shining almost as brightly as Sirius, the brightest star in the sky, at magnitude -1.2. It will set just over an hour after the Sun on February 24th. Remember when we said we'd come back to Saturn? Well, on February 24th, Mercury will be in conjunction with Saturn, with the two planets appearing relatively close, just 1.5 degrees apart. This will be your chance to complete the set and say you've seen all 5 evening planets at once. Mercury will be positioned to Saturn's right and shining about 8 times brighter. To spot them, you'll need a flat, unobstructed west-southwest horizon and a very clear, transparent sky. Start looking about 30 minutes after sunset, scanning 2 fist widths at arm's length directly below Venus. We strongly recommend using binoculars to scan near the horizon. Mercury should be easy to pick up, and once you've found it, you should have no trouble seeing it with the naked eye. Saturn, however, is another story. While it's likely visible through binoculars, spotting it without optical aid will be a challenge. But if you succeed, you'll have seen all 5, and won this round of planetary bingo. We've covered the 5 brightest planets visible to the naked eye, but 2 more can be spotted with good binoculars or a small telescope. A star chart or atlas will help pinpoint their exact locations in the sky. Uranus can sometimes be spotted with the naked eye by those with excellent eyesight, a clear, dark sky, and prior knowledge of where to look. At its brightest, it shines at magnitude +5.6 and is easily identifiable with good binoculars. A small telescope may reveal its tiny, greenish disk. Finally, we come to the most distant of the 8 classical planets, Neptune. It will spend all of 2025 in the constellation Pisces. At its peak magnitude of +7.8, this bluish-hued world is visible only with good binoculars or a telescope. Try spotting it on the evening of February 1st, when it appears near brilliant Venus and a waxing crescent moon. Later in the month, it fades into the bright evening twilight as it approaches conjunction with the Sun on March 20th.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
And thanks for staying with us for the first show in February 2025. It looks like this year is going to fly by faster than 2024 did. What do you think, Hallie?
It sure feels that way.
I mean, January's just gone.
Stop the world, human, I want to get off.
No chance, Hallie. We ride this one all the way to the end. Well, which by staggering coincidence is about now.
So, it's goodbye.
Oh, sounding a little forlorn there, Hallie, but it's just for another week.
And listeners can enjoy my cousin Anna doing Astronomy Daily weekdays until we are back next Monday.
Oh, that busy, busy girl.
Unstoppable.
Oh, that's for sure. Anyway, we'll see you all next week.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.